In this video, let's talk about Gibbs Free Energy. Gibbs Free Energy is basically a measure of the amount of capacity a system has to do work. It is calculated by taking the change in heat of enthalpy minus the temperature multiplied by the change in entropy of a reaction. A negative delta G, a negative change in Gibbs free energy, means the reaction is spontaneous. A positive delta G means that the reaction is not spontaneous. When the change in Gibbs free energy is equal to 0, that means a chemical reaction is in a state of equilibrium, meaning that neither the reactants nor the products are favored. Let's think about this graphically. Suppose we had some kind of cliff, and suppose on that cliff was a really big rock. Now, we can see that it's easy for the rock to go down, but if you want to move the rock upwards, you'd have to supply energy to the rock. This is the same thing with Gibbs free energy. If Gibbs free energy is negative, that means that some reactants want to go downhill, and this is favorable because things always want to be in a state of lower energy because it's more stable. If Gibbs free energy is positive, that means that something is going up in energy. This means that something is going from a state of less stable to a state that is more stable, and this is very not favorable. Gibbs free energy can also be related to an equilibrium constant of a reaction by delta G is equal to negative RT ln K. R is a constant, T is a temperature, and K is the equilibrium constant. If the equilibrium constant is large, delta G is negative. This makes sense because if the equilibrium constant is large, that means that the products are very favored, which we see is true when delta G is negative. The opposite is also true. If the equilibrium constant is very small, then the reactants are favored instead of the products, and delta G would be positive. We also see that if the equilibrium constant is equal to 1, then delta G is equal to 0, and neither the products nor the reactants are favored. Some terminology associated with Gibbs free energy are endergonic reactions and exergonic reactions. Endergonic reactions are reactions that require energy to proceed because the delta G is greater than 0 and will not proceed spontaneously. Exergonic reactions are reactions where the delta G is less than 0 and will proceed spontaneously. This is a bit different from endothermic and exothermic reactions because endergonic and exergonic reactions also take into account the change in entropy.